Hello, welcome to a demonstration or an illustration on how you can use t-statistic and critical value for hypothesis testing. So in this particular demonstration, I'll assume that you've got some reasonable background in understanding hypothesis testing and kind of just illustrating an alternative way of actually using the t-statistic and critical value is one way of either rejecting the null hypothesis or not rejecting the null hypothesis. So in this particular case, we've got a data set of academic performance reports where school districts will be compared with the state averages. Right, this is a very common analysis that's widely done, and I'm hoping that it's going to be very, very helpful here. So what you'll notice here is that I've actually done some initial calculations of simpler calculations that we actually need to know and kind of left out the t-statistic and critical value sections so that we can walk through that together. However, I still want to walk you through what I've already done so that at least you've got some working knowledge of what the objective was. So to begin with, we calculated the school district averages, and again, it's nothing but just finding the averages of the range of each subject area, as you can see right there. And then I also did the standard deviation. This SD actually represents standard deviation, to measure the data dispersion within each particular subject area. And then after that, I called in the state mean with the state averages that are actually provided here. So all I'm doing here, I'm just reading them here so that they're actually available for further calculations. And then of course the sample size was basically a count function that I actually used to count how many data points are actually available in each particular range. As you can see, they are all same sample size. Then I did calculate a standard error, and the standard error will actually be needed to calculate the t-statistic, right? But however, what is standard error? It's a fairly straightforward formula. Again, you need to know what that actually means, and it's actually based on the standard deviation. Now, standard deviation divided by the square root of the sample size will give us the standard error. So basically, standard error, it's an alternative title to it will be the sampling error. So the size of the sample do have an impact on helping us understand the validity of that particular sample from the population, right? So basically that's what I did here. As you can see, I said standard deviation divided by the square root of the sample size. Now we can move on now to the t-statistic. Now, really, it's important to also understand the difference between t-statistic and critical value. Now, t-statistic is a numerical measure that helps assess the difference between the sample data and the population mean, right? So, in other words, what we'll be doing here is we'll be measuring the difference between the school averages and the state mean, right? So, we will be our t-statistic is actually designed to measure that, and then we adjust it for the sampling error. That's what our t-statistic really is going to be. And in other words, it's essentially a signal to noise ratio that's indicating how far the sample mean is from the population mean in terms of standard errors or sampling errors, right? So the higher the sample size, the lower the standard error is likely to be, right? Because we'll be much closer to reality. But we know that in practice, it's very difficult to count every item, in other words, to come up with the population number every single time, because it takes a lot of effort, takes a lot of time and so forth. That's why we tend to extract a sample from that particular population, right? So that's basically a much more elaborate way of understanding what the t-statistic is. What is the critical value, which we're also going to calculate, is basically a threshold or a cutoff point beyond which you reject the null hypothesis. So we're going to use the t-statistic and the critical value to determine whether we should reject. In other words, we're going to make the decision right here. So let's go ahead and calculate the t-statistic. So equal sign, open parenthesis, and we want to find the difference between the district averages and the state averages, right? Divided by the standard error, which we've already calculated there. And then we can see that our t-statistic is actually going to be 3.3092. And of course, we can use our fill handle here to copy the same formula across. And then we're actually able to see that it's automatically going to calculate for each particular category. All right. So then the next thing we want to do is to calculate the critical value. Right, and again, as I've already mentioned, critical value is a threshold or a cutoff point beyond which you reject the null hypothesis in hypothesis testing. So it's actually determined based on the chosen level of significance, right? Usually denoted as A, which is alpha, right, which represents the probability of rejecting a true null hypothesis. All right, so basically, how do we determine the cutoff point? Critical value can actually be read out from from tables, right? And in tables, you can actually find those values on, even on the internet or at the back of most finance books or statistics books. You're likely to find those. But there's also a function that is actually in Excel that you can actually use to calculate the critical value, right? So we enter the equal sign, and it's called t.INV to t because it's actually two-tail a function. And then you can see it does begin to guide us. What is the probability? The probability is 1 minus 0.95. So in other words, it's 95 confidence level. So the alpha is going to be 0.05. So that's why we say 1 minus 0.95, which means it's actually, the answer is going to be 0.05, which is the alpha, right? Comma. And then the degree of freedom is the sample size minus 1. And before we know it, we've actually calculated what the critical value is. Now, what you will also observe is that when we are trying to determine what the lower critical value would be, it's the same value but negative, right? So, So we actually tend to use exactly the same value. So if using a two-tailed test, as you saw that we selected the function that was calculated the two-tailed test, the critical value will have two values, positive and negative. And you compare the absolute value of the t-statistic to these critical values. So again, here, what we'll do, we don't have to recalculate this. We just say equal sign minus, and then click on that value, which means that when we copy this across, right, it's actually going to be making sure that it's going, the lower critical value is going to be negative. Then, of course, then when it comes for us to make the decision, right, we actually look at our t-statistic. Is it positive? If it's positive, then we are comparing it with the upper critical value. If it's negative, we compare it with the lower critical value. So in this case, we can see that all our t-statistics values are all positive, right? So all we have to do now to make a decision is we want to compare critical value. So critical value, we know, is actually our cutoff point. So if the t-statistic is higher than our cutoff point, which means we reject. So for the first one here, we reject the null hypothesis, right? So if this t-statistic is lower than the cutoff point, we do not reject. Do not reject. Okay, so we can see here that it's fairly straightforward that the rest are lower than the cutoff point, so therefore we do not reject for the rest. We only reject on the first one because the t-statistics is actually higher than the cutoff point, right? So there you have it. We are now able to see that we've actually been able to perform some hypothesis testing here, where we were trying to determine whether the null hypothesis, which says that the mean average is equal to state mean, right? So the null hypothesis is actually rejected for the first one, and for the rest we do not reject because the values are way smaller. All right, so otherwise that's all I have for you here. Just trying to do a quick demonstration for you how you can actually use the t-statistic and the critical value to perform hypothesis testing. Thank you so much for watching. I hope you found value in this particular illustration, and hope you'll be able to refer to it in future as you as you find yourself having to deal with statistical calculations, the more advanced statistical calculations that can really make a huge difference in decision making. Thank you so much. And again, if you like the video, like it, share it, and please subscribe. Thank you so much, and bye for now.